In this video, we're going to be tackling the LeetCode question, merge intervals. So in our day-to-day life, we encounter intervals all the time, but very few people, including programmers, are going to go around and be thinking of intervals all the time. And luckily for us, LeetCode did us a solid. Instead of the intervals being posted as actual timestamps, they made them just into whole numbers. So this little array right here actually represents an interval, and we're going to be given multiple intervals at once, but this is just one interval. So intervals play an important part in our day-to-day lives because think about it. In your scheduling software, whatever you use, Microsoft Teams, you probably have meetings, and sometimes these meetings need to be merged. Sometimes we have two time intervals that need to be merged. And in our case, let's just say we want to merge meeting 2 with meeting 1. Now it would be meeting 1 and 2, and then we would get rid of this interval just like that. And that's the whole entire concept of what we're about to do, a merge interval. But we need to be a little bit more precise. That was kind of a dumbed down version, I guess, of an interval. We need to get a little bit more precise with our actual intervals. And let's just say we have an interval between 1 and 10, and we are given 2 intervals. If we have an interval of 1 and 3, and if we have an interval of 2 and 6, it's going to look a little bit something like this. As you can see, we have 1 and 3 and 2 and 6. But how exactly is this merge going to happen? That's the $1,000,000 question. Like, how is this even going to happen? Well, it's very simple. Just look at these two numbers right here. The only thing that you need to pay attention to is just these two numbers right here, because these are the key deciding numbers if it's actually an interval or not. If this number is less than this number, you have an interval. That is, boom, 100%. That's how the algorithm works. That's how you're going to actually do the merge. You just check if this number is bigger than this number, and if they are, you're going to merge it over. That's 100%. That's how merge intervals work. And all that we're going to do is we're just going to go through a chain of intervals one by one, and we're going to do this exact same thing. Is 2 bigger than 3, or is 2 less than 3? It is. So we're going to go ahead. We're going to do the merge, and then we're going to do the exact same thing. So go ahead, get rid of that. Go ahead, move over to the next one. We're already at the next one. So is 6 bigger than 8? No, it's not. We're going to keep going. Is 10 bigger than 15? No, it's not. That is our interval. So let's go ahead. Let's start implementing this algorithm, and let's jump over into IntelliJ. So we are inside of IntelliJ. First thing that I'm going to do is I'm going to create a brand new Java class. I'm going to call this solution. Let's go down here, start typing out the actual method. We're going to return an array of arrays. So this is a nested array. You could also call it a matrix. I'm probably going to call it a matrix because it's a lot easier to say. This is going to be our base case. Mainly we use base cases to prevent our speed from going down, because if you don't catch these, it will run the whole entire program. We do base cases like that for mainly speed. So let's go into here. Now what we need to do is we need to have a place to store the newly created interval list that we're about to make. So this is where we're going to store it, and we're going to go ahead, bring in our classes. We need to bring in our list and our array list. And here's where we're going to sort. Now, we're going to sort by the start time. That may be confusing right now, but I'll show you here in a second. So we're going to say intervals, and yeah, the AI is going to do everything for us. And basically what this confusing function means is that we're going to sort by the start time. So there's many ways that you could sort this, all different types of ways, but what we're going to do is we are going to sort, and we're going to do so by the first number, aka the start time. So let's go ahead, let's go back, and let's start creating our actual algorithm in a for loop. So what I'm going to do is create just a standard for loop. I'll say int I is equal to 0. So we'll start at the very first element, and we'll iterate through the whole entire length of intervals. Now what I'm going to do is I'm just going to create some variables to store our data in so it doesn't get really confusing. I'm going to call this temp min, and I'm going to call this temp max. And what these variables represent is this is the start time, this is the end time of whatever current whatever current interval we are at. So what we're going to do is we're going to obviously be iterating. We'll be iterating through everything one by one. And what those variables stand for is this is going to be the first one, and this is going to be the second variable. So hopefully that makes sense. So now what we're going to do is we're going to create a while loop. Within this while loop, what we're first going to do is we're just going to do a quick out of bounds check. If you are within a while loop and you don't do out of bounds check, it's going to give you index errors. So that's the reason that we put this here. Here's where things can kind of get a little bit confusing, but trust me, it looks confusing, but it's not confusing at all. So what we're going to do is this is where we're going to check to see if the actual merge can happen or not. Sometimes merges can happen, sometimes they can't happen. And next thing that we need to do is we actually need to change this to less than, and we need to change this to max. So this needs to be temp max. Both of these need to be less than. And here's what this logic actually means right here. This is a row, this is a column. Whenever you see the +1, it means you're moving over to the right. If you saw a negative here, it means you'd be moving over to the left. So we're going to move over a row. We're going to move over a row, and we're going to basically check. If it's still confusing you, this is how we're going to check if the merge is going to happen. If this number is less than this number, a merge can happen. But we also have that second extra little piece of logic that I actually conveniently left out because I knew it would confuse people really bad if I gave both of those examples at once. So I only gave one example, but basically what this means is also if this number is less than this number, another merge can happen because if this number were less than this number, the whole entire interval would exist inside of the whole entire other interval, which you could obviously merge. But that's kind of a weird case that, like I said, I kind of had to purposely leave out so I didn't confuse people. So before we move on, we need to do something very important. We need to make sure that we have parentheses wrapping around the merge interval logic. And the reason that we need to have parentheses wrapped around this part right here is because we need to make sure that this boundary check runs before this. Because if we don't check the boundaries before we run this code, we're going to run into a lot of errors. Next thing that we're going to do, once we determine if it's a merge interval or not, we're going to reset the temp max. We're going to reset the finishing value. What exactly does that mean? Well, if it is a merge interval, if this number is less than this number, we basically can get rid of these middle numbers right here and just make the ending time the max. So whatever the higher number is, we can put it right there. And that basically obliterates our actual numbers in between, and we can just basically merge them. Pretty neat, huh? So let's go ahead, let's go back. In theory, if we have merge intervals through the whole entire set of intervals, this thing could keep iterating. We could keep incrementing I, and we need to check down the line if there's intervals. But if it's not an interval, it's going to escape the while loop, and we're going to add it. So essentially, regardless of whether it's a merge interval or not, we still need to add it. But we still also need to check the merge interval within the while loop. And lastly, at the very end, we are doing everything within an actual list right now, but what we need to do now is we need to convert it over to an array. And what we're going to say is new int, and basically what this code means inside of here is that we're turning it into a matrix. So you need to specify that. So that's pretty much it. Let's go ahead in here. Gonna go ahead, get out of this full screen right here, and let's go ahead, toss this into LeetCode, see what we get. So bring this over. Going to go ahead, put that in there, shift this over, make it look good. Let's go ahead, hit that run. Yes, thank you, God. Let's hit the submit button. Let's see what our time complexity is. So we're pretty high. We've got a pretty fast algorithm here. Our time complexity is n log n, and our memory is n. Congratulations, we have passed the interview. Hope that you guys enjoyed this. If you did, make sure to smash that like button. Make sure to smash that subscribe button. And as always, thank you for watching.